This is podcast 3.1 for chemistry, and we're going to talk about the types of chemical bonds that there are. So, general definition, a chemical bond is a force of attraction that holds two or more atoms together. We want to know, how are these compounds forming? Why do they form from all the elements that we have on the periodic table? So why do atoms form bonds? And the whole reason they do that is for stability. And stability means lower energy, and it makes them like the noble gases. Because we know the noble gases are stable, they are inert, they do not react, they don't want to form compounds. Because they already have full outer shells, they have all the electrons that they need. And that just makes an atom more stable, less reactive. And there's two ways that they can form these bonds. You can either transfer electrons or you can share electrons. And I put this picture in here because this is a picture of hydrogen bonds. It's an actual picture of a molecule. So this is a picture of hydrogen bonding. You can see this is the molecule, these are the individual atoms, and there's carbons and hydrogens and oxygens, but you can actually see it in here. This is 1 nanometer. And remember your nanometer, drinking chocolate milk, you have the micro, and then you have the nano. So this is 1 times 10 to the negative 9th meters that we're looking at right here. So actual atoms, where we see these are the atoms that would fit into that other picture. So these are some breakthroughs that they've just made recently. We can see these pictures of these atoms and we can actually see the forces interacting between them. So pretty cool stuff. All right, so there are 3 types of bonds that you need to know. There's ionic bonds, covalent bonds, and metallic bonds. We said that you can either share electrons or you can transfer electrons. And the transfer of electrons happens with ionic bonds, so electrons are transferred. And ionics normally happen between a metal and a nonmetal. The metal is the positive part of an ionic bond and the nonmetal is the negative part. Because if you think of the periodic table, that was not very good drawing. It looks kind of like that, but we know that that stair-step line that you have right here splits up the nonmetals from the metals over here. And we know metals have a fewer number of valence electrons, so they want to lose them, so they form the positive charge. Our nonmetals have more than 5 or have 5, and they want to gain electrons to get to 8. So your metal is always positive and your nonmetal is the negative part. And if we look at the picture here, this is how sodium chloride forms, salt. The sodium atom loses an ion and gives it to the chlorine. So it goes, the electron goes from here to here. The electron transfers, and you can see the change in size. And that different attraction now, because this is positive and this is negative, is what holds these things together. When we have shared electrons in these covalents, we have a picture here of hydrogen. You usually get it between 2 nonmetals, so 2 elements off this side of the zigzag line. They come together and they share the electron that they have to get a full outer shell. So hydrogen has 1 valence electron. It wants to have 2 to be like helium, so it gets together with another hydrogen, and then they just share. So when they share, it's like they're helium because both of them get the benefits, I guess, of having a full outer shell even though they're sharing them. And then the third time, which we spend not a lot of time on, is the metallic bonds. Metallic bonds have a sea of electrons is what they call it. So you have all these positive nuclei of these metals. So say this is silver. You would have a bunch of the silver nuclei, and we know that the nucleus has a positive charge. And with metals, their electrons are free to kind of roam around. So the electrons from each atom kind of roam around and they're shared amongst everything here. This is one of the reasons why metals are so conductive, is because they have this sea of electrons that allows electricity to travel so easily through them. We are going to focus on the ionic and the covalent aspect, though, of bonding. The big difference in the bonds is because of electronegativity differences, and electronegativity values are on the back of your periodic table. If you flip it over, you can see a little table there that gives you some numbers. Those are electronegativity values. If you find the difference, and remember difference means subtraction, so if you subtract whatever two elements you're looking at, you can get an idea of what type of bond will form. These are both covalent. There's just two different types of covalents. And this is the ionic. So if your difference is greater than 2 when you subtract them, you're more than likely going to have an ionic bond. If your difference is less than 2, then you could either have a polar covalent or a nonpolar covalent. And we'll talk more about those in just a second, what exactly they mean. But polar covalent is an unequal sharing of electrons, so one atom is going to pull harder on the electrons than the other. And then nonpolar is they're going to share very evenly the electrons. And then remember, ionic is when the electrons actually get transferred. So looking at properties, ionic versus covalent compounds, they're pretty much opposites of each other. An ionic compound is a metal and a nonmetal together. They are really highly conductive, and that's because you end up with the positive and the negative charges. They have a transfer of electrons, which means they are a lot more polar because the electrons go from one atom to another. They have really high boiling points, really high melting points, less volatile. That means maybe they're harder to smell. If something's volatile, it means it goes into the gas phase really easily. And these are really stuck together well, so it's hard for them to escape into the gas phase. And then when they form solids, they're usually lattices or crystals. So really pretty structures, very structured. It's not random at all. With covalent compounds, it's all opposite. So you have two nonmetals together. They're going to be less conductive. They're sharing electrons. They're going to have the lower boiling points, lower melting points. They're just not as strong as the ionic compounds are. They're more volatile, so it's easier for them to go to the gas phase. And they get discrete units. So they don't form these really big structures, these really big crystals. They stay kind of broken down into little units. And then talking about the ionic bond for just a second. So metallic cation, remember cations are your positive, non-metallic anion, which is your negative part. All molecules are neutral, which means your charges must cancel. So really quickly, if we remember back on your periodic table, the charges here of everything, plus or minus 4, and then it goes minus 3, minus 2, minus 1, and then these don't have a charge. When we're doing this, we need to, if we're building sodium chloride, remember sodium has 1 valence electron and chlorine has 7. So chlorine needs to gain 1 more electron, sodium wants to give it away. So what they do is they transfer, and then we end up with our sodium with our positive charge and our chloride ion with the negative charge, and they get stuck together like this because opposite charges attract. Well, we can do this with all sorts of things. So say I picked magnesium and I wanted to put it with fluorine. Well, magnesium has 2 valence electrons, and fluorine with chlorine has 7 because they're in the same family. Well, magnesium is going to give one of these to the fluorine, but it still has another valence electron here. So this is why magnesium would bond with 2 fluorines, is because that second valence electron on magnesium would join with the fluorine. So this would be MgF2. So when we're doing these and we're writing these compounds, we have to remember that the charges have to cancel. The number of electrons transferred has to be equal. We can't lose them somewhere. So it's really, 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 really important that you can remember these charges that these things form. Covalent bonds, on the other hand, are your nonmetal and nonmetal, so we don't have to worry about charges, and they're sharing electrons. You can share electrons evenly, which means you're covalent, or you can share them unevenly and you're polar covalent. And there's a diagram here to explain it. The picture on the top shows just a covalent compound. So it's really evenly shared. Maybe it's a hydrogen with another hydrogen. Usually your covalent compounds are between the same element. So it might be hydrogen, like a hydrogen bonded to a hydrogen, or an oxygen bonded to an oxygen, or a fluorine bonded to a fluorine. You usually have to have the same element bonded to itself in order to have a covalent compound. The polar covalents happen when you have one of the atoms that is more electronegative than the others. And a really common one is water that we know of. Oxygen is really electronegative as compared to hydrogen. So what it does is oxygen hogs the electrons from hydrogen, and it ends up becoming kind of a negative charge, and these become a positive charge. So we call those partial charges because the electrons aren't completely transferred. They're just taken from the hydrogen, and they're just kind of hugged closer, I guess, to the oxygen than they are. They're not evenly shared. And this is one of those things that gives water all the special properties that it has, but we'll get into that later. So polar covalent is an uneven sharing, covalent is an even sharing of electrons. And then if we want to practice then, what type of bond is this? So if I look between sodium and chlorine, sodium is a metal, chlorine is a nonmetal. Metal and nonmetal, ionic. And we're just going to label things as ionic or covalent. We don't have to split covalent into covalent and polar covalent. Carbon is a nonmetal. Oxygen is a nonmetal. So two nonmetals makes that covalent. This is a nonmetal, and there's two of them. So this would also be covalent. Calcium is a metal. Oxygen is a nonmetal. So this is ionic. Hydrogen is a nonmetal. Oxygen is a nonmetal, so this would be covalent. And then titanium is a metal, chlorine is a nonmetal, so this would be ionic. You mainly look whether it's a metal nonmetal or nonmetal nonmetal, and you do that by looking at the periodic table. You want to look at that stair-step line, remembering that the nonmetals are to the right of that, the metals are to the left. So that's how you can tell what type of bond it is. That'll be important later on when we're trying to figure out how to name these things. And that's the end of this podcast, so make sure you wrote down the different properties between ionic and covalent compounds, and that you know how the transfer of electrons or sharing of electrons defines what type of bond it is.